right, everyone, in this video, we're going to learn how to create trig ratios using right triangles. And so when we talk about trig ratios, we have three that we're going to learn about. But before we do that, I want to make sure we understand the different parts of a triangle when we look at a specific angle. And so what we're going to do is we're going to look at this first triangle, the one where there's the alpha symbol. We're going to think of this alpha symbol. It's just like an A, so we'll talk about angle A. So since I'm focusing on angle A right here, the one I've marked in blue, I need to make sure I know which sides are opposite, adjacent, and are the hypotenuse in that triangle. So if I'm looking at angle A in blue, the side opposite of that is the one that's directly across. And so this is considered my opposite side. And the hypotenuse is pretty easy to figure out because it's always the longest side. It's also the side that is across from the right angle. And the adjacent side is the side that basically touches or is part of angle A, but is not the hypotenuse. And so this is considered my adjacent side. Now, if I switch and I look at the other triangle, which has angle B, which is technically a beta sign, if I look at angle B and I ask you to name the opposite, adjacent, and the hypotenuse sides, you'll notice that with angle B, my opposite side is really what was the adjacent side for angle A, and the adjacent side was actually the opposite side when we were talking about angle A, and then you'll notice that the hypotenuse never changed. Okay, so the reason why we need to be able to identify our opposite, adjacent, and hypotenuse sides is when we talk about the three trig ratios, which are sine, cosine, and tangent, those three trig ratios are going to tell us which sides of the triangle that we're going to create a ratio for. And so when it comes to the sine ratio is the opposite side to the hypotenuse side, or over the hypotenuse. The cosine ratio is when we take the adjacent side to the hypotenuse. And then the tangent ratio is when we compare the opposite side to the adjacent side. Okay? And so whatever side is opposite, adjacent, really depends on which angle that you're talking about. So let's take a look, and before we kind of jump in and create some specific ratios, I want us to assign some numbers to these sides of our triangles. So I want us to, with that first triangle on the left, let's do sides of 3, 4, and 5. And so we're going to apply those same measurements over here, 3, 4, and 5. So if I'm asked to find the sine ratio for angle A, so I'm going to look at the left triangle here because that's the one that has angle A. The sine ratio means I need to do the opposite side over the hypotenuse side. So when I look, my opposite side is 4 and my hypotenuse is 5. So when I ask for the sine of angle A, that ratio is going to be 4 over 5. Now, when I turn around and I ask for the cosine of angle A, the cosine means I have to do the adjacent side over the hypotenuse. So my adjacent side was 3 over the hypotenuse, which was 5. And then to find the tangent of angle A, I have to do the opposite side, which is 4, over the adjacent side, which is 3. So that's all that trig ratios are. The sine, cosine, tangent, all they're doing is telling us which sides we need to look at. So let's go and let's look at the second triangle, the one on the right, where it has angle B or angle beta. So in this one, it says to find the sine of angle B. So now I have to look at my adjacent and opposite and hypotenuse sides from angle B's perspective. And so now, knowing that sine is opposite over adjacent, my opposite side in this right triangle is really 3, but my hypotenuse didn't change. If I want to set up the cosine of angle B, cosine is the adjacent side. So if I start at angle B, my adjacent side is side 4 over the hypotenuse. And then lastly, if I do the tangent of B, the tangent ratio is the opposite side, which is 3, over the adjacent side, which is 4. So when you look at the different ratios we can create, you might notice that these two ratios were the exact same, and these two ratios were the exact same. So it's important to understand that the sine of one angle is going to be equal to the cosine of the other angle. And then also, I can see the cosine of A was equal to the sine of angle B. And then something else you might notice, if you look at the tangent ratios, notice how they are reciprocals of each other. Notice how one is 4/3, but then the other one is 3/4. So the tangent of one angle. So you might be thinking, how am I going to remember all of these trig ratios? Well, we have kind of an acronym that we can use, and that acronym is called SOHCAHTOA. Let me get my pen. So SOHCAHTOA. And so the first letter is our sine, cosine, tangent. And then the second two letters represent the ratio of the sides that we would create. So as you guys proceed, especially in these beginning days when you're first learning your trig ratios, I highly recommend that you write SOHCAHTOA at the top of your paper every single time. And so the more you write it, the more you're going to remember what your trig ratios stand for and which sides that you have to look at. And then also too, you may not have realized this, but if you think about, if I add angle A plus whatever angle B is, think about what they should always equal. Hopefully you thought to yourself that they should always equal 90 degrees. And the reason for that is I already have a 90-degree angle in my triangle right here. I highlighted it in green. And I know there's 180 degrees in a triangle. So if I take that 90-degree angle out, that leaves me with 90 degrees left over. And so those two angles, angle A and angle B, will always add to 90 degrees. So let's do one more practice problem. Okay, so in this bottom practice problem, it says to find the ratio for sine, cosine, and tangent of angle A. So before I even get started with writing, I'm going to write SOHCAHTOA here. And I'm also going to label my sides as adjacent, opposite, and hypotenuse. And so I'm basing which sides are which by the fact that I'm looking here at angle A. So if I go straight across, this side here is my opposite. This side is my hypotenuse because it's across in the right angle. And then because this length of 15 is attached to angle A, this is my adjacent side. So if I want to create a ratio for the sine of angle A, the sine of angle A is the opposite over the hypotenuse. And so the opposite side is 8. The hypotenuse is 17. The cosine ratio is the adjacent side over the hypotenuse. So my adjacent side is 15 and my hypotenuse is 17. And then the tangent ratio is the opposite side over the adjacent side. So I'm going to create a ratio of 8 to 15. So hopefully between the examples we did above and this example, you understand how to create your trig ratios.